Step-by-step exam solutions. Okay, maths class. Training you to excel. Subscribe, like the video, share the link of this video with others. Click the alert button so that you receive the next video when it is released. Drop your comments for a better service. Okay, maths class. Present 5 steps to exam success. Step 1, pray. Step 2, plan. Step 3, prepare. Step 4, preview. Step 5, perform. Okay, maths class. Present step-by-step exam solution to matrices. In this video, we'll be looking at matrix operations. And the topics we'll be studying are: number 1, addition of matrices. Number 2, subtraction of matrices. Number 3, multiplication of matrices. The objective of the presentation. Number 1, we should be able to add 2 or more matrices. Number 2, we should be able to subtract a matrix from another matrix. Number 3, we should be able to multiply a matrix by, number 1, a scalar, and then number 2, by another matrix. Let's go straight to the video presentation. Matrix operations. What do we mean by matrix operations? Matrix operations include the following basic mathematical operations. Number 1, addition. Subtraction, number 2. Multiplication, number 3. Finding the inverse or calculating determinants. All these are referred to as metric operation. Metric operations are the backbone of linear algebra in mathematics. It powers everything from computer graphics to AI production. Matrices also help us to manipulate grids of numbers, rectangular arrangement of numbers to solve equations, transform data, and model complex systems, turning mathematics into a powerful tool for real-world innovation. So you can see that this topic has very wide applications in mathematics, in science, in the medical field, and so many other areas. So we are going to really take time to study this. So we are going to go straight to the first one, the first metric operation, addition of matrices. Now, what do we mean by that? 2 matrices can be added or subtracted if they satisfy some conditions. What then are the conditions they must satisfy if we are going to add them? Number 1 condition, they must have the same order. Please take note of that. They must have the same order. And what do you mean by the matrices having the same order? A matrix is having the same order. We say also they have the same dimension. So they must have the same order or the same dimension. So if that condition is satisfied, then we can actually carry out matrix operation. That's number 1 condition. The number 2 condition for 2 matrices to be added is that elements in the same position must be added together. That means element in the first position should be added to the element in the first position of the second matrix you are adding, or the 3 matrices you are going to add, or more than 3 itself. So now, we'll see that the first and 2 conditions. So number 1, if we have a matrix that's given by m times m by n order, m by n dimension, and then we can add it to another matrix having another order m by n. That means they must have exactly the same dimension. They should be the same thing in size, and all the elements in the corresponding positions are the things we are going to add. What are we saying? Let's assume I have this matrix here. Let's say this is 2, this is 1, this is 3, and this is 4. And then I'm going to add this to another matrix, and this is let's say 4, this is 7, and this is 8, and this is 9. So now we have these two matrices to add. Now looking at this calculation, you can see that number one, this one is a 2 by 2 matrix. This one also is a 2 by 2 matrix. They have the same order, they have the same dimension. So if the first condition is fulfilled, then we can add these two elements in the same position. So that's the second condition. So please take note of that. We cannot just go do anything outside that. So they must be the same dimension, and then element in the same position must be added. So now we go straight to addition of matrices proper. Now, to add the matrices, number two condition, as I said, add entries or elements in the same corresponding positions. Now look at this example. We have this matrix. So now, what do you think is the dimension of this matrix? How many rows do we have there and how many columns? Now look at the second matrix we are going to add to that. How many rows and how many columns do we have in this matrix? Without much talking, you see that the two matrices have the same dimension. If you look at this one have 3 rows. This is 3 by 2. This one also have 3 rows. This is 3 by 2. So the first condition is satisfied. They must have the same order. Now the second condition says that all the elements in the same position, the yellow should be added to the yellow. And then the blue should be added to the blue. And then the green should be added to the green. So that's the condition for us to add matrices. So now let's add this. So now we are going to have A plus B, meaning we're adding A and B. This is A and this is B. So now we have going to add the elements in the same corresponding position. This is what happened here. We added this and this to get this. Right? Okay. Now look at the next one. We added this and this to get this. So that is it. So now we must always remember that we must add elements in the same corresponding position. So now we complete that. So we have all this added. Then we now simplify. 6 plus 12 is 18. Minus 1 plus 9 is 8. And so on and so forth. You are going to have the final answer, or the addition of the two matrices will give us another matrix having the same dimension as the original matrices we added. So please take note of that. It's very important. So now we have seen addition of matrices. We can also, this one now is a rectangular matrix. We can also add square matrices, like I can give you 2 by 2 matrices to add. For example, if I say add this, if I have these matrices 2, then 3, minus 4, 1. Then we are asked to add this to another matrix, let's say 0, 3, 4, 1. What will be your answer? So write that down and think about it. So let's continue in our presentation. Let's continue in our presentation. So now we're going to look at the next one, subtraction of matrices. The same condition as addition of matrices. It's not going to be different from that of addition because the conditions still remain the same. What is the first condition? They must have the same order. Number 2 condition, elements in the same corresponding positions must be added. Now look at those 2 matrices we handled before. We have them. A is this and B is this. Now how do we add them? We are going to subtract elements in the same position. So now you can see clearly all the elements in the same position. Look at them. For emphasis, let's look at them one by one. Now, Let's look at them one by one. So now, you see, this is 8 minus 12 because we are subtracting. The next one is minus 1 minus 9 because we are subtracting. The next one is 6 minus 4 because we are subtracting. Now, following the same pattern and the same thing, we can go around and we can now get the subtraction of everything. So the final answer we are going to get will be this minus this will give us minus 6. Minus 1 minus 9 will give us minus 10. Then 6 minus 4 will give us 2. 7 plus 7 will give us 14. And then 5 minus 2 will give us 3. 11 plus 13 will give us 24. This is the subtraction of these two matrices. Please subscribe, like this video, share the link of this video with others. Click for alert so that you receive the next presentation. So now, on your own, this is just an assignment for you. Can you add these two matrices and also subtract them? You do that on your own. So now let's go to the next slide to continue our discussion. The next thing we're looking at now is what? Multiplication of matrices. Remember, we have gone through the first metric operation, addition of matrices. We have gone through the second metric operation, subtraction of matrices. Now we're looking at the number 3 metric operation, the multiplication of matrices. Now, there are two types of matrix multiplication. Two types. Number 1 is called the scalar multiplication. And number 2 is called the matrix multiplication. Scalar multiplication means we are multiplying a matrix by a number, by a constant. Matrix multiplication means we are multiplying a matrix with another matrix. Let's take the first one, scalar multiplication. In a scalar multiplication, every entry in the matrix is multiplied by the constant outside the bracket. Every entry, every element, every member of the matrices is now multiplied by the constant outside the bracket of that matrix. Now look at this matrix now. If A is given by this matrix we are looking at now. Now the question now says we should then find 2A. We should find 2A. Now let's find 2A. 2A means, in other words, what I'm saying here is that we are supposed to find 2A. So now what's the scalar? What's the number? What's the constant in this multiplication? Of course, the constant is 2. The scalar is 2. So now let's go ahead and do that. So now we are going to have that 2A will give us a 2 outside the bracket, then multiply by that matrix we are multiplying. Now, like I said before, it means that these 2 multiply every element in that. So these 2 will not be here again because we already sent it into the bracket to multiply every entry of that matrix. Every entry of that matrix has now been multiplied. So now, if we do that now, that means 2A will give us, the first one will give us 2 times 2. What would that give us? 4. Then 2 times 7, 14. 2 times 6, 12. And then you follow the same way. You go down. So now this is the final answer after multiplying this original matrix by this scalar 2, by this number 2. So this kind of multiplication is known as a scalar multiplication. Now let's also suppose we are asked to find something like 3A. They are asked to find 3A. That means this is a negative vector. So now how do we go about finding 3A? So once again, we are going to multiply every element of this matrix by what? Minus 3. So now, that means each element is now multiplied by minus 3. So now let's see what is going to happen. So that's what you are going to have. So every element in that matrix will be multiplied by minus 3. Then after getting that, then we're now going to multiply. Look at the first one. Minus 3 times 2 is what? Minus 6. Minus 3 times 7 is minus 21. Minus 3 times 6 will be minus 18. Minus 3 times 5 will be minus 15. Now, minus 3 times minus 2 will give you 6, and then and so on and so forth till you complete the multiplication. So the final answer will now give us those answers we mentioned before. So now, in this case, now you see that here we are multiplying a matrix by what? A matrix, by a number, by a scalar, by a constant. So we move to another slide to see more examples on the multiplication. So in this example you are seeing now, we are multiplying the matrix A by a scalar, the constant lambda. So that means every element is multiplied by that lambda. So we continue the multiplication, and then you are going to have this. So this is a scalar multiplication. Scalar multiplication is one of the easiest multiplication you can handle in mathematics at any level, because just like elementary multiplication. So now we are going to move straight to the next aspect of our study, and that is multiplication of a matrix by a matrix, or matrix multiplication. We are multiplying a matrix by a matrix. So now, if we have a matrix, let's say the matrix A is having a dimension. What's the dimension of the first matrix, as you can see from there? This first matrix is having this dimension, m by n. The second matrix is having another dimension, n by p. So now the two matrices we are aiming to multiply, they have different dimensions. But we're going to find out what will be the condition for us to be able to do that multiplication. Now, the first condition is that the multiplication will exist. The matrices are conformable if their product exists. They are conformable if the product exists. Now, if the product exists, that means we are multiplying A and B, and that will give me a matrix A times matrix B. This multiplication will be possible if the number of columns in A is exactly equal to the number of rows in B. The number of columns in A is equal to the number of rows in B. And also the same way the other side. So if that condition is satisfied, then that multiplication is possible, will exist. Now look at this example we have here. The first matrix, as you can see, is given by what? M by n. That's the order. Now the second matrix is given by what? N by p. Now what do you notice? Look at the inner part of this expansion. Look at the inner part. What do you notice at the inner part? N and n. The number of columns here is equal to the number of rows here. So that's the condition for two matrices to be multiplied. Then we say the multiplication will exist, or they are conformable. So now that's the condition. So anytime this condition is met, know that those two matrices can be multiplied, and when you multiply, you get an answer to those to the multiplication. So now the matrix we are going to get, the answer we are going to get will be a new matrix. For example, I said m by n, then the other one is n by p. So now the middle one tells us that the two matrices are conformable, the answer exists. What is left after that? You are going to have m by p. This will be the dimension of the answer. So the answer you are going to get will be whatever that's left. This and this will be the dimension of the answer you are going to get at the end of multiplication. That means you need to know the dimension so that it will guide you as you are multiplying. So now we're now going to look at what I've just said, and then we have that. And when the product this is possible, we say that the matrices are conformable. I've said that already. I mentioned all this already, so I don't need to talk about them again. So when we finish, the answer we get will be going to be by M by what? P. Now look at the two matrices. Now let A be equal to that and B is equal to this. So the first thing you need to do before you start the multiplication is to check whether the multiplication is possible. Is it conformable? The first one here, what's there? It has 2 rows and 3 columns, so it's 2 by 3. Now, the second one has 3 rows and 2 columns. Now, look at the middle one now. Clearly, you can see you have 3 and 3. So therefore, that means the product will exist, is conformable. But the answer we're going to get will be a 2 by 2 matrices, right? That's okay. That means you'll be expecting to get a 2 by 2 matrices in this multiplication. So now let's carry out that multiplication now. So we have the matrix confirmed already, that's conformable. So now we carry out the multiplication. We have this. So they have the same, the inner dimension is the same. So therefore, we know that that will be. So the product will have this as the answer. So now let's now multiply, since we know that the product exists. So now, how then do we multiply a matrix by another matrix? Now let's see how that can be done. Please be patient and be observant so that you can get the steps. So now, that will give us another matrix that we say is going to be what? 2 by 2 matrix. So that will be the answer. Answer will look like this. Then how do we get C11 and all these things we have here? Now let's start. C11. That C11 means I multiply the first row by the first column. Multiply the first row by the first column. So when we do that, C11 will give me, how do we carry out the multiplication? Please pay attention. The first element here, 8, will multiply the first element here. Then the second element will multiply the second element. Then the third element will multiply the third element. So that's how we carry out the multiplication. So if that is the way we are going to do that, let's carry out that multiplication now. We are going to have 8 times 2 plus 3 times 1 plus 9 times 3. That's what you're going to get here. And when you multiply that, you're going to have the answer as 46. You do all this multiplication and add them, you have 46. Now the same thing we're going to do to get C12. So in this position now, we're going to multiply because C12 means row 1, column 2. So we're going to multiply with row 1, then column 2. And in this multiplication, of course, now you know what to do. The first element here will multiply the first one. The second will multiply the second. And the third will multiply the third. Then you add everything. So that will give us 8 times 5 plus 3 times minus 2 plus 9 times 1. Now when you carry out that multiplication and addition, you are going to get your answer as 43. Then the same way we are going to do for this. Now that means we are dealing with column 2, row 1. That's column 2, row 1 element. So now this is column 2 and this is row 1. So I'm going to multiply this row 2, column 1. So we multiply that because it said 2, 1. Yeah, row 2, column 1. So we're going to have this 2 multiply 2, 7 multiplies 1, and 5 will multiply 3. Then you now simplify that, and then you get your final answer as 26. Now this C22 means the second row multiply the second column. So we have 2 will multiply 5, 7 will multiply minus 2, 5 will multiply 1. So we have that as our answer. So we have that. So we have done that. We have gotten the element of the product AB. So then we now say AB will be equal to putting those elements in their corresponding position. So that is the multiplication of a matrix by another matrix. So now this is a rectangular multiplication. Let's pick another example, a 2 by 2 matrices. The multiplication of a 3 by 3 matrices will be done in another video, because that will take time and we need to really spend enough time and carry out enough explanation for your understanding. So now let's look at another example. You have, given that P is this and Q is this, find PQ. How then do we solve this? How do we get PQ? So simple. Let's dive into the solution. To find PQ, that means we are multiplying P and Q. So we are multiplying P and Q. So we have that P and then we have Q. So then, like I already said before, you understand what I said. The first row will multiply the first row. You add up to get the element in that position. So now we have that row, first row multiplying first column. So if we carry out that, it's going to give us a matrix. So that will 2 times 8, 16, plus 6 times 1, 6. 16 plus 6 is 22. Then we now take the next one now. First row multiplying second column. First row multiplying second column. That's 2 times 1 is 2. Then 6 times 5 would be what? 35. So what would that be if you add everything? That gives you 32. So the same way, you go to the next one. Row 2, column 1. 5 times 8 is 40. 3 times 1 is 3. 40 plus 3 will give us a 43. Then the last one. What will be your answer? Remember, row 2 will multiply column 2. If you do that very well, what answer will you get? 20. Now, given that m is this, and then this one, n is equal to this, then you are asked to find mn. Please, not pq. You are asked to find mn. Okay, so even if we work with pq, you see the same thing. So now, how can we solve this? First of all, is this product conformable? Is it possible? Let's check if that multiplication will be possible. How many rows do we have here? 2 rows, 3 columns. You have 2 by 3 matrices. The second one, okay, the first one is 2 by 2. The second one is, now what do you notice? Look at the middle. You have the same thing. So the product is possible. But the answer we are going to get after multiplication will be what? 2 by 3 matrices. The dimension will be 2 by 3. Please take note of that because you need to know. So now let's go ahead and start the multiplication. So we have this. So we are seeing that the product is possible. So now, as usual, we multiply. First row will go with the first column. 5 times 2 plus 11 times 2. If you do that very well, what will be your answer? 5 times 2 is 10. 11 times 2 is 22. If you do that, you are going to have, your answer will be 32. Okay, that's it. That's right. Now, the next one, you multiply first row. First row is going to multiply second column. What do you think will be the answer? 5 times 5 is 25. 11 times 4 is 44. 25 plus 44 is 69. Then we moved first row, multiply the third column. What should be there? 5 times 7, 35. Then this times this is 66. If you add them, what will be the answer we'll get? 101, of course. Then we have finished with that. Then we'll now move to the second row. This will multiply this to give us the answer here, and then multiply the other one to give us this answer here, multiply the other one to give us this answer here. So we have that. Now, we now have another assignment for you. So the assignment now is you should multiply these matrices. That's the assignment for you. You should multiply these matrices. So now you should multiply these matrices. So that's an assignment for you. Please take time to do this multiplication. That brings us to the end of this presentation. Remember, this is assignment 2, 3. So please do that. Please remember to subscribe, like the video, share the video, and click for notification. Thank you for watching.